Welcome to episode 4 of the AI Labs podcast. It's a pleasure to have you listening today. My name is Tim Mathis and I'm sitting with Josh Chettier. And today we are going to give you a roundup on the state of play in all things AI. Very interesting tweets from Elon Musk this week about AGI, baby AGI, being achieved by Dojo, and then shortly followed by Don't Look Up, AGI are not a comet. Seems to be a little bit of a paradox. We're then going to move on to the non-consensus on risk assessment of the future of AI. And then really the meat of the podcast today, we're going to be discussing autonomous agents, their business application, what they are, and how they are the next obvious evolution from the copilot. But before we start, a quick joke by Google Bard. I asked it to tell me something witty, and it said, "I'm not saying I'm perfect, but I've never made a mistake that I can't blame on a human." Josh, what are your thoughts? Don't Look Up, AGI not a comet, Dojo achieving baby AGI status. All of these concepts, and this sounds typical Elon Musk, doesn't it?
Yeah, no, definitely does. I think his opinions on this is sometimes not very consistent, one may say, but his claim to have developed baby AGI, and just for the listeners, what that is essentially sort of an artificial intelligence system that's designed to emulate cognitive abilities of a human, but not necessarily a very advanced human, an infant or a baby, some sort of lower level artificial general intelligence. And that's sort of seen as one step in the direction to eventually achieve full AGI, but first through this sort of intermediate step. And yeah, that is a bold claim. And if he has achieved that, of course, kudos. His Tesla Dojo supercomputer, which originally was designed for their computer vision processing and machine learning, has now made its way into their sort of autonomous driving, full self-driving systems. And I know that he has expressed previously his desire to have his Teslas develop personalities that's sort of customized to the driver and develops in tandem with the driver. And maybe this sort of AGI system that he's developed sort of goes in tandem with some of those sort of developments he has up his sleeve. But I think it's interesting nevertheless. I think, I guess we'll have to wait and see what he comes up with.
And his other tweet, which is "Don't Look Up, AGI not a comet," obviously tying in with this idea that he thinks that we, not long ago, was calling for a pause on the development of AGI. And really the reason he was doing that is he felt that this is potentially going to be an existential threat. So I do find it somewhat ironic that they own some of the largest supercomputers and they're trying to train a AGI up from a vision perspective as the learning modality, perhaps rather than language. And yet at the same time, he is saying, "Here comes the comet." I think that's the really big warning. So Mustafa Suleiman wrote a book called The Coming Wave. I think we both read it. It's an interesting book. Mustafa Suleiman is one of the early visionaries in the artificial intelligence wave that we see now. And he has come up with this concept of pessimism aversion. I think it's an interesting concept, and it's something we should be cognizant of when we think about how we embrace the change that's coming. Josh, your views on it, can you maybe describe to the audience what you understand pessimism aversion to be as described by Suleiman?
So as described by Suleiman, it's a form or type of cognitive bias, essentially, that leads to a sort of misguided analysis and sort of or rather that sort of misguided analysis arising due to an overwhelming fear of confronting potential dark realities in relation to technology, and sort of just a tendency to look the other way, to have sort of an aversion towards confronting some of the dark potentials of, in this case, artificial intelligence, but broadly any sort of technological phenomenon.
So a little while ago, there was an article published in The Economist, and the article was really about whether or not we need to be scared of an AI-driven Armageddon. And although I'm not scared of an AI-driven Armageddon, I do think that there's potentially a massive wave of disruption coming. And I think that when we start talking about Armageddon and risk, we're obviously talking about the scale and potential impact of the technology. Whether or not that's used for good or bad remains to be determined. But to quote that article, what was very interesting is The Economist ran a study where they asked two cohorts of people, domain experts and super forecasters, what they thought the threats of artificial intelligence, nuclear engineered pathogens, natural pathogens, and then non-anthropogenic, so that might be things like comets, what they thought that threat, the likelihood of such a threat occurring in the next sort of 80 years, so looking out to the year 2100. And they grouped the threat into two areas, and I'll close the loop on where I see the analogy shortly. But The one is catastrophic risk, and they defined catastrophic risk and the second one being extinction level risk. So catastrophic risk was death of more than 10% of humans within a 5-year period. And then catastrophic extinction level risk are defined as death of most of humanity with at most 5,000 survivors. Okay, so 2 pretty severe scenarios. But what came out of the study, which was really, really interesting to me, is that normally you see there to be not too much of a difference between how people see the risk when you look at domain experts and super forecasters. When you look at engineered pathogens, you see the difference in the risk to be fairly significant. So this is the idea of taking genome sequencing and synthetic biology to sort of its extremes. There you see the risk of catastrophic risk to be forecast to be about 3% by domain experts and about, let's call it 0.5% by super forecasters. This pattern is much more severe when you look at artificial intelligence. So in the domain expert bucket here, the domain experts are forecasting there to be a 12% risk of a catastrophe happening where death of more than 10% of humans. So that would be something like 800 million people. Whereas the people who are professional forecasters are only seeing that risk at about 2%. So let's just look at that again. 12% of domain experts think that there is catastrophic risk coming from artificial intelligence in the next, call it 80 years, and only 2 or 3% of super forecasters. When you look at that at an extinction level risk, the numbers drop a bit, and you have the domain experts calling the risk out to be about 3%. Either way, these numbers are very, very staggering. And what they tell me is that there's a major bifurcation happening in the way that we understand artificial intelligence, and the difference that we're seeing in people who are in the trenches, either in the research game and really understanding what the gains that we make in replicating effectively human intelligence, and those who are sitting on the periphery is growing and enormous. And I think that this ties back to Suleiman's idea of kind of a pessimism aversion, but also just a general blindness that's caused by the grind of daily distraction and really not knowing what's going on. The message is that we need to take this stuff seriously, not from an existential threat perspective necessarily, because I think other people will worry about that, and I do think that's something we should worry about, but much more about what it means. Let's take existential in the context of business and say, what is the existential business threat that artificial intelligence is bringing downstream in the very near future? To me, the message is that we need to all wake up and take stock. So with that said, the next wave that is coming is very much this wave of autonomous agents. So we've gone from copilots, and in South Africa, copilots are actually really just in their infancy. They're just arriving on our shores. But the next big thing that we've been playing with and that we're excited about are autonomous agents. And I'm going to hand over to you, Josh, to give us a view of what both are. Feel free to comment on my opening preamble, but also if you want to just jump in and talk to us about copilots and then autonomous agents and what they mean and how we can potentially use them, that would be really interesting. I've got some use cases I'd like to discuss too.
Thanks. Definitely keen to talk about autonomous agents and copilots. I think first to start on copilots, I think we have every right to be excited about it. As you say, it's on our shores, and it's going to provide a massive boost with regard to human-assisted workflows. So, but that we mean the ability for a human to use an AI as an assistant to really accelerate, augment their productivity. And I think to sort of bring this picture to life in relation, especially to what we want to discuss more in depth, and that's AI agents. I think let's take a step back and talk about what the sort of as is status quo picture is. And I'm going to use an example I picked out in a publication by Mosaic Ventures, and they published an article around copilots and autonomous agents that I thought was really insightful. And they used an example of a sort of traditional leads generation funnel sales context where the as is picture within, I imagine most companies, most sales departments, is to have some sort of domain expert that they hire whose responsibility is to identify leads and then to themselves write and send outreach emailers, content, etc., and then log that onto some sort of CRM system. So you can see that as sort of the human, and then some sort of software that sits outside of them that they interact with to try and to store that data and to deliver the content to the customer. When we talk about moving to an AI-assisted workflow, we're talking about having essentially a co-pilot that sits alongside that sales agent. So while the sales individual or agent might still identify leads, it's then the AI assistant or co-pilot that will then actually potentially generate some of the content that's needed to reach these clients, to actually then send those emailers out and to log all of that within a CRM. So you can see that as sort of an AI assisted workflow. I think this has a lot of potential to accelerate, not just in this example, sales agents, but a variety of people across business, right from executive level down. The ability to just have an assistant that sits alongside you and can help your workflows really accelerate and augment the sort of outcome. But what we talk about with AI agents is to actually go a step further and to say, can the AI agent as an autonomous entity handle all of or most of that, from the actual generation of leads to the outreach, to the logging of the CRM, to the communication, etc. And therefore the role of the human who still remains in the loop is one of managing the AI, is just to sort of sign off to see if what it's done meets some of the criteria and quality assurance. And then the AI agent, by definition being autonomous, subsumes a lot more of the previous tasks that were under the gambit of the sales agent in the sort of traditional workflow, and even to some extent the assisted workflow. To explain that again, we are going from adding an AI as an assistant to a human, to having the AI subsume about 80% of the tasks and having the human redefine their role as a sort of a manager and a quality assurance executive within that loop. And I think that's quite powerful. And I think that's a technology that's being made possible through something called autonomous agents. And I think we can get into a little bit about what technically has made this possible, how it differs from sort of a static pipeline within large language model chains. But I'm not sure if you have any questions around that, any thoughts, observations, maybe before we get into that.
No, I think that's great. I suppose the idea, I mean, if you're thinking about these co-pilots, and again, for many of us, they're quite new, there's obviously a lot of thoughts. I can see, again, the adoption of them potentially being inhibited by sentiment and about this kind of, maybe it's not pessimism aversion as much as it is just a case of like the inertia in the system around changing the way that we do things. You know, the idea of having a language model as a sparring partner to bounce off ideas versus picking up the phone and just chatting to somebody else. You can immediately feel that there's something seemingly missing there. So there's definitely just an observation, is that there's going to be kind of wave of businesses that start at ground zero using co-pilots across every different domain. And in some ways we need to be careful, because they're going to have an advantage where they don't have the social inertia of organizations that have already got a well-defined approach of doing things. So picking up a phone and chatting to a mentor, or whether it's in software dev or asking for peer review on code, or, you know, in the creative space, just asking other people for their ideas. So something to be mindful of in the adoption of these co-pilots and everything that's happening is just our own organizational inertia. And I think about that often. I think about it as being a big barrier. And I suppose I wonder where that leaves our business's sense of culture. Where do co-pilots play in the culture space? And perhaps that's a comment for another day. But I mean, your initial views on that. I mean, does it start to disintermediate some of the social interactions that we have in the workplace?
Yeah, I think that might be quite possible. I think time will tell. In some sense, it's difficult to anticipate, especially since it hasn't scaled to the point where it probably will scale to in the short term with regard to adaptation and where it fits in within established workflows. But I think that potential definitely exists. But I guess in this sense, I'm a little bit of an optimist, and I think there will be some sort of adaptation that we can apply to that. It might mean some very human adaptations with regard to the way we do team building and interact that needs to maybe ramp up to compensate for some of the disadvantages that comes with what you've just described. But yeah, time will tell, I suppose.
Okay, no, that's great. And I mean, I'm also optimistic on the whole. I just think there's a bit of a shift coming. Let's move on. So co-pilots, I think the concept is relatively straightforward. You've got an artificial intelligence that really is serving up to you nudges or bits of information that you need, maybe checking your work across any different domain. and helping you. I mean, as the name suggests, you're the pilot, it's the co-pilot. Then we move into this domain of agents. And I think autonomous agents in particular are like a very interesting concept because they start to bring in, I suppose they start to shift, as it sounds, the locus of control towards the agent itself, which is actually not a human, and start to be able to perform what at least on the surface look like reasoning tasks, and the ability to then sort of ask a model a question, get a response back, validate whether or not that response is accurate or not. And that might be in software dev, it might be in, fact checking, might be in a number of different domains, but like help us just at a very high level understand this idea of autonomous agents and why they're so profound. I know we had some things like LangChain. I don't know if that's a good example, but no, Microsoft is now bringing out some of their autonomous agents as well. I mean, as we are learning, no idea lasts very long as a unique advantage to any one company. This stuff seems to all out be in the public domain, and the rapidity with which everybody's catching up to the same level is really quite something staggering considering the complexity of these tasks. But just tee us up here, what exactly at a conceptual level is an agent and then an autonomous agent, and how is it different from a co-pilot?
I think to explain that, like we should just take a step back to look at what we mentioned things like LangChain and what they've established just 6 months ago, in fact, with regard to static pipelines. That is to say, we've probably all used large language models, whether it's through the front end, GPT, Playground, Llama, etc. But when you talk about using it at scale and in an enterprise, you need robust pipelines, and you need a pipeline that can handle volume, velocity, different data types, etc. And if you think of a large language model is, after all, just a model. And so a model has input on one side, output on the other side. And so when we talk about input, there's a lot that needs to happen to the data from a data loading perspective, a file data type conversion perspective, converting the text into sort of the mathematical vectors that these large language models need within an embedding space. There's a lot of things that need to happen in short before the model gets the data and has the ability to generate content in response. And of course, on the other end as well, what comes out needs to be in many cases structured in a particular way for particular API calls within particular data formats, given again things like volume, velocity, etc. And that's sort of what's needed to build a sort of robust pipeline. And that's what LangChain has helped achieve. Essentially, they've developed a very, very robust API framework that connects all of those pieces together. The things needed on the input side, from data ingestion and transformation to embedding layers, the language model itself, the ability to do so in a very modular way, of course, to swap out different language models, and then on the output layer as well to customize what comes out. And that is what LangChain was able to achieve. But what I've just described is a static pipeline. In other words, when one builds this engineering pipeline with a large language model at its center, we are defining what's the input, what at each stage the language model has access to and what it should do. While when we talk about something a bit more dynamic and flexible, what if we could have an AI decide what next steps to take, given what has happened previously, given what tools it has access to, and given what steps it's arrived at through efficient planning.
So this is sounding a lot like almost like reasoning. And when you start to talk about this, you can almost hear the concept of and I think it is this, you really at a very high level, what you're doing is saying, hey, Mr. AI, I'm going to give you a goal. And I want you to evaluate every step that you have along the way to achieving that goal. And if it's not working, try something else potentially, but keep on going back to that goal. And the static pipeline that you're talking about is less powerful in the sense that if it kind of goes off course in the beginning, it's going to end up where it ends up because it's just going to sequence through each one of those steps that you've described in a pretty linear fashion. But here, you've got almost like a reference check that happens at the end of each one of the stages in this pipeline, where there's some sort of, let's call it reference back to the stated initial goal through a series of possibly other agents. Can get to this idea of adversarial agents in a second as well. But you can see how this is starting to get much closer to how we do it as people. And I think all of these steps that we've seen, if we go back to the beginning of this podcast, are very rapid builds towards something that's starting to approximate human intelligence. And now, rather than saying, Or if you go, you 2-year-old child intelligence go through steps 1, 2, 3, 4, and 5 and tell me what you get on the other side. We're now saying you're a 9-year-old. I'm going to tell you need to solve this problem, Mr. 9-year-old, and evaluate your steps all along the way and see whether or not you're getting closer to that goal. Be a bit self-critical and then reevaluate as you go along. I don't know if that's a fair summary. I'm sort of using metaphor, and sometimes that's a bit dangerous, but that's how I see it in my head.
Yeah, I think that's right. I think you mentioned reasoning, and I think it's been said before by some that GPT can't reason or LLMs can't reason. And I think that to some extent we can debate whether that's true or not. But I think for me, what's evident is that an LLM within a framework, this particular framework being autonomous agent, has the ability to reason. And I think how that's possible. Maybe I can get into a little bit more of the details into what happens within an autonomous agent system that approximate what we refer to as reasoning, and why I think it is these AI agent systems that, as a whole, does reason, I contend, as opposed to maybe making a judgment of whether one standalone LLM does reason given a simple prompt. So,
and Josh, before you go into that detail, I want to point something out to our listeners, and that is that some proponents, some of the commentators in this game say that we build in alien intelligence. And I actually quite like that, because I think the thinking trap that we get into is to say, does an LLM, is it really producing real language, or is it just producing kind of the next, almost a mechanistic deconstruction, but to say all it's really doing is producing the next letter, and that there's something sort of intrinsic to language that we're never going to emulate. I mean, that's the kind of, we've discussed it before, that's kind of the Chomsky-esque kind of view of these things. But what we do seem to be arriving at, and I want to point this out, is things that are indistinguishable from human language and things that are indistinguishable from human logic. So to get lost in the weeds about whether or not it's true human logic, to my mind, doesn't matter. As long as what it does is indistinguishable and the outcomes are similar, who cares whether or not what it's really doing is sort of, from a purist perspective, logic, or whether from a purist perspective it's language. At some point in time, the stuff all converges on the same outcomes. It looks the same, it smells the same, it produces the same outcomes. Whether or not it's actually the same in how it gets there, to my mind, becomes completely irrelevant. Sorry, I just wanted to add that in before you go to sort of a more detailed deconstruction of what happens.
Yeah, no, definitely well described. So just to go back into a little bit of the details here. So if I can describe at a high level the components of these autonomous AI agent systems, they're very roughly made up of the following components. One being planning, and we'll get into a little bit about that. Two are the tools that these AI agents have access to, in some cases other AI, which is really, really powerful for the ability of one AI to communicate with another AI when it decides itself it's needed, because it doesn't have the requisite skills or knowledge, but the other AI does, and we'll get into that. As well as memory, which I think in some interesting ways, sort of, although I do agree we're more likely creating a sort of alien intelligence than a perfect replica of human intelligence. There are, of course, mirrors between the two, and we can also discuss long-term and short-term memory. So let's start with planning. And I think this was made possible through a paper released just this year, in fact, if not late last year. And it was a paper on chain of thought reasoning. And it was an idea by some researchers to improve the reasoning abilities of LLMs or LLM responses by eliciting what they call a chain of thought reason. And the best way to illustrate this is, I think I'll just refer to the actual example in the paper, although I probably don't have the full details of the example. I'll just try and paraphrase. They tried asking an LLM a sort of problem-solving question. It's sort of those type of questions you ask a child. I guess goes back to the AGI, the baby AGI comment or topic we discussed earlier. But it's a very simple reasoning task to us humans, but it's very easy for an LLM to get tripped up. It goes something like, you have 3 red balls in a specific container, you then get another container with 2 blue balls, you then mix them around, and it's sort of that nature where you mix different objects, counts. You're required to sort of understand what's happening within those sequences, some basic arithmetic, reasoning skills, temporal reasoning, etc.
Is this an object permanence problem? The sounds we're talking about,
parallels
to developmental psychology, sounds like an object permanence problem for an AGI, baby AGI.
Yeah, exactly. It's very, very similar to an object permanence problem, which I think babies only grasp at a certain age. I can't remember what that number is, but before which they're somewhat prone to not understanding that an object persists even outside of clear visibility to them.
So at the risk of digressing, that's why everybody can be so funny when they go up to a baby and say, "Here's the balloon, look," and then they hold it behind their back and it's gone, and the baby thinks this thing has just disappeared from existence. It doesn't, it takes a while before the baby wakes up and says, "Dad, that's not that funny. The balloon's behind your back. I've got a mental model of the fact that it's no longer there." So it feels like it could be something like that.
Yeah, it's very, very, very similar to that. And they basically just ask, they present this problem to GPT. I can't remember right now if it was 4 or 3.5, maybe at the time the paper was released, there's only GPT 3.5, but I think GPT-4 also has these problems. But if you just present that blank to one of these language models, there's a very high probability it might give you the wrong answer. It'll give you an answer, but if you actually analyze what the answer is, it's wrong. And what these researchers were able to discover is if you just ask and this is actually quite an amazing thing, if you just use the words, think step by step, just using the word in your prompt, you elicit a chain of thought reasoning within the LLM to decompose the problem into steps. And you can further provide examples of, for example, that example I gave you with the balls, provide that to LLM, and then you actually give it the answer, but sort of through a step-by-step process. Then you give it an equally complex question, maybe not using balls, maybe using some other object and different colors, different situation. Given that it was shown how to reason through step by step, given that small example you've given it previously, and that you've used the word step by step, it actually then learns to arrive at the right answer by following a sort of chain of thought reason. And I think that's quite profound.
So now we need to wade into the deep weeds here a little bit to understand what's going on, and you'll hold me to be honest. When you create a complex sentence, an instruction like you have, which requires a whole bunch of sort of complicated thoughts to work out what's going on, and you give it to an LLM, if you go back to the way that an LLM's working, it's predicting the next likely sentence structure. When you force it into a answer that says step by step, each one of those steps, the outcomes of the solution to those steps that are predicted by the LLM have a vastly constrained number of potential responses, and therefore you get a more accurate deconstruction. So by what you're effectively doing as you interrogate the large language model is you're breaking down the number of outs, which could be accurate, and every single time you do that in an LLM, your fidelity of response goes up. Now, it's the same idea, and if this is complex, we can spend a bit of time on it, but it's the same idea as saying to an LLM, what am I likely to say? The cat, and then just leaving it open. Now, the number of outs, predictive outs that the LLM has when you say the number of cats, ... are really significant. They're a number. In the same way, if you give it a very complex, sort of jumbled around paragraph, the number of outs are also quite significant. If you tell it to deconstruct it step by step, with each deconstructed chain of thought, the responses that it's likely to predict become more narrow and more specified. I think that's what's going on. I think that's what's happening, which is why it's so much more accurate. Can you think of another reason, or does that sound plausible?
Yeah, that does sound plausible to me. I think at the heart of the benefits of decomposing things, even for a human, when it comes to planning, when it comes to organizing, so taking something that's very, very large and complex and breaking it down into a smaller task. I think that sort of principle is at play here with task decomposition. And I think something you've mentioned there about the outcomes of each, or the outcomes these AI comes to following each one of these decomposed steps. These are what's called observations or traces that it actually leaves behind that can be used for future tasks of the AI to then reflect back on. This is one of the other
validate. So if you can deconstruct this into task by task, then another agent can look back and say, right, was task 1 accurate or was it not? And it can play a referencing role, an arbitration role.
Yeah, exactly. And this is what one paper refers to as self-reflection. And as we talk about reasoning, and this is introducing another sort of, I guess, a word from human psychology, the ability to self-reflect or to enable self-reflection to correct past mistakes. And I think that's one of that combined with the chain of thought reasoning and the other techniques people are experimenting with to even to further break down, decompose tasks for LLMs in a very sort of a streamlined manner that seems to be yielding some positive results. I think something called tree of thoughts reasoning as well, essentially doing the same thing but deliberately breaking it down into a sort of tree-based, if you think of like a decision tree, if you will, with different ways. So that's the first component, planning, the ability to, again, decompose tasks, think essentially about what steps are needed next, etc. And this is the first component, a very powerful component of these AI systems. But following planning, there's then tools and action. So after it's decomposed these tasks down, and it has to then make some sort of action following that reason, for following its planning process. And this is quite powerful because some of these actions may be, as I said previously, to reach out to other AI, to come to either to elicit its abilities. For example, reaching out to a vision AI model. If the agent decides what's being asked of me requires, as one of the decomposed steps, to scan an image, for instance. It itself, as a large language model, doesn't have the ability to do OCR, for instance. I mean, GPT-4 Vision perhaps will change that, But as we stand here, it then reasons about the need to call an AI that has that ability, and if given access to, and this is where the human can constrain the possible set of tools. One of them being the internet. It can be a calculator. It can be custom Python functions. It can be API calls to other AI. You can then call that AI to initiate the action and so forth. And that's quite a powerful ability of these AI systems to chain the language models, to chain AI.
So I had a conversation recently with someone who was talking about his conversation with an actuary friend of his. And they were asking the question about whether actuaries would ever be able to be, whether or not actuaries would ever be replaced by AIs. And the conversation from the actuary went, no, they won't, which I can imagine is kind of the place that most people go to. And the reason that they actually gave is that an AI wouldn't be able to work out what variables to put into a model. Okay. So of course I said rubbish. And I want to use these agents as an example for that problem to explain how an agent would play out a problem like this. So I'm going to paint a picture here. You create a problem statement for a large language model that says something like this. What are the risk factors that need to be considered when building a death date model for cohort of people living in South Africa to cost a life insurance premium, as an example? Okay. That would then spit out a number of criteria on which to consider, like health, socioeconomic connectivity to, I think things like social connectivity are like one of the predictors of death, et cetera, et cetera, et cetera. Then, so from there, you've got like a list of particular criteria. You could then have an agent which then says, I'm going to go now pick up each one of those things and take the next step connected to something like Wolfram Alpha and deconstruct. We now go in from a big problem statement into all of the different reasoning steps. Take one of the next reasoning steps and say, now, how would I do that part? Get a response back from, let's say, it's got access to Wolfram Alpha, which is a big mathematical and statistical library for those who don't know. And I think that's access has been granted to some of these. This is an example of something that an AI agent could have access to. It could spit that back. You could then have another agent taking the result of that and evaluating whether or not that component is accurate and delivers the ultimate outcome of assessing risk on one particular part of the subcomponents that we described in assessing actuarial death age of a cohort of people. You can see how that could bounce back between what's almost like natural language reasoning of saying kind of what are the things that I need to consider here, and then going into these deep statistical libraries, building the models, and you could take it further. You could even then overlay things like code interpreter execution steps like we have already in GPT-4 and saying, produce the Python code to model it and see if it works. Here's the access. And I see absolutely no constraint. I see nothing magical about what the actuaries do in here, from describing the problem and very broad steps through to taking these agents, giving them access to other tooling, building the models, checking the models that they work, and bringing it all back into sort of an abstracted framework and then a fully functional model. Could this be the kind of thing that you'd use an agent for? I mean, what are your thoughts? Am I getting this right?
Yeah, definitely. I think that essentially speaks to the AI managed workflow we described, where we give a host of agents different tools, access to different information, and for them to bounce off ideas between them and have the actuary as a human in the loop to sign off, to check for quality assurance. I mean, to just expand on your example there, starting off from that initial list of features, you can then definitely have an agent create the simple model, whether it's a logistic model, some random forest model, whatever it is, given the sort of regulatory constraints on some on the actuarial field against using very complex black box models. And then you can just then have an agent compute the feature importance and then iteratively run the model with different feature sets, different feature combinations to arrive at feature importance, etc. And I think definitely of an autonomous agent or a host of autonomous agents within this AI managed workflow that redefines perhaps the role of the actuary within the loop, but still produces sort of beneficial outcomes at the end.
Any pearls we want to leave our audience with before we sign off for the weekend?
Yeah, I think just a little bit on some other practical business use cases and things like that of the nature of what we described. I think for the audience to maybe go out and research for themselves, read up on it. I think things like consumer behavior simulation is a big one. I think the idea there is you actually create something like Sims. It's quite a new novel idea. So you create a virtual city of virtual avatars that's sampled from the attributes of which are sampled from a real world population with regard to indicators such as gender, race, personality traits, etc. But you essentially have each one of these are agents that respond, that have a memory, that have the ability to plan, that have the access to tools. And the practical use case here is to essentially do consumer behavior research on these some individuals, because these some individuals are sort of almost baby AGI reasoning agents that have properties that are made up of the general population, or the not necessarily the general population, even just the population of interest that you're interested in. And so you're able to introduce interventions, see how they would react, etc. So there's a lot more detail in there, but definitely something to look out for. The idea of using generative agents for simulation. Drug discovery is also massive use of agents with the ability to access to tools from chemical chemical decomposition to other compute systems to discover novel drugs. And yeah, I think it's a really exciting space, and I'm really excited to see what Microsoft does with AutoGen. They recently leapt into the agent field, so it's no longer just LangChain and Hugging Face in the agent game. I think Microsoft's AutoGen might just take the top spot there. So yeah, great conversation, and I hope people found it as interesting as us.
Great, thanks, Josh. And just to touch on a couple of the cool reading artifacts that we mentioned in this conversation today, for those who want to go and read a little bit more, we spoke about this. I don't know if we actually specifically mentioned it, but the paper that was written that got all of this going with autonomous agents was a paper called React. The actual paper name was Synergizing Reasoning and Acting in Language Models. It came from a conference this year only, the International Conference on Learning Representation. So check that out if you want to read it more. We also spoke about a really good book by Mustafa Suleiman. Check that out as well. The book is called The Coming Wave. And as Josh was talking now about simulated agents, I did immediately start to think of Nick Bostrom and his ideas of simulation hypothesis. So check that out too if you're interested in a bit of extra reading. Thank you very much for listening, and we'll chat to you again soon.